Hello, everyone. All right, so with 9C, we're really going to focus on actually writing the quadratic equations from the roots. So this is really it's a similar situation to actually doing a quadratic regression. So we're going to learn how to do these both by hand and using the calculator doing a regression model. So just to kind of start off, we're actually doing 9B backwards. So we're doing the factored form. So to start off, we're actually going to solve a couple of these problems by factoring. So we have x squared minus 5x minus 14 equals 0. So in order to start, we're going to do our ABC method. So your A value is 1. You're going to have a B value of negative 5 and a C value of negative 14. So you're going to start by finding A times C. So we're going to be doing 1 times negative 14, which is going to give you negative 14. Now remember, we want the factors to add up to your B value. So our factors of 14, we're going to have 1 and 14, and 2 and 7. So in order to get these to add up to a negative 5, we want a negative 7 and a positive 2. So negative 7 and a positive 2 are going to match negative 5. So those are the factors I'm going to use to split the middle. All right, so down here, that negative 5 is going to split. So we're going to have x squared minus 7x plus 2x minus 14 equals 0. So just as a reminder, remember the order does not matter. So if you want to put the 2x in the front, you can. All right, so now I'm going to actually do grouping. So I'm going to group the first two terms together and then group the last two terms together. All right, so I want to find the greatest common factor between the first and the second group. So in the first group, in this x squared minus 7x, I can take out an x. So when I take out that x, I'm going to have x minus 7 left. And in the second group over here, between 2x minus 14, I can take out a 2. So when I take out that 2, I'm going to have x minus 7. And I'm setting that equal to 0. All right, so notice your two binomials in parentheses, the x minus 7, these are the same. So that's what I'm going to take out. So I'm going to have x minus 7. And my new binomial over here in blue, it's going to be x plus 2. And that's going to be set equal to 0. All right, so if you can recall from 9b, now I want to take each of these binomials and I want to set them equal to 0. So I'm going to take x minus 7 and set it equal to 0. And then I'm going to take x plus 2 and set it equal to 0. All right, so when I do that, I'm going to have plus 7 on both sides over here. So we're going to have x equals 7. And over here on the right, I'm going to subtract 2 on both sides. So I'm going to have x equals negative 2. So now I want to write my solutions as my final answer. So I'm going to have x equals negative 2, comma 7. All right. So now we're going to do the same idea for the next one. So notice how on this next one here, this is actually to a third root, or to a third power, not a root. So that means we can have up to 3 solutions on this one. So what I'm going to do first is I want to determine if I can take out a GCF. So looking at 3x cubed, 9x squared, and 6x, what I can take out is a 3x. So when I take out that 3x, I'll have x squared plus 3x plus 2 equals 0. All right, so same idea here. Now you want to factor just this inside trinomial right here. We're going to leave that 3x on the outside alone. All right, so I'm going to kind of skip a few steps. I'm going to kind of skip the factoring part. So I'm going to do 3x, and when you factor it, you're going to get x plus 2 and x plus 1 equal to 0. So that's your factoring part. All right, so now I'm going to take each of these components, and I'm going to set them equal to 0. So I want to take 3x, I'm going to set this equal to 0. Then I'm going to take my next component. So I'm going to take this x plus 2. Now I'm going to set this equal to 0. And last but not least, if I can find a color. Oh, there we go. These colors are not the best. I am sorry. All right, so I'm going to take each of these individual components of my polynomial and set them equal to 0. So now I want to actually solve each of these for 0. So this very first equation over here on the far left, I'm going to divide both sides by 3 since we're multiplying. So I have x equals 0. And then over here with my x plus 2, I'm going to subtract 2 on both sides. So I'm going to have x equals negative 2. And similarly over here, subtract 1 on both sides. So we have x equals negative 1. All right, so now I'm going to write this as my final answer. So I'm going to have x equals negative 2, negative 1, and 0. All right, so just remember, just as like a little math notation, always write your answers in order from least to greatest. So even though we found 0 first, it's actually our greatest solution, so I wrote it last. So you don't have to, but it's like riding a bike with square tires. It's weird. All right, so that's kind of the review part. So now we're going to move on to the next part. So this is actually doing a quadratic regression by hand. So all the steps have been laid out for you. So if you ever get stuck at some specific point, you can kind of refer back to the steps. All right, so step 1 is you're going to have to identify the roots. So one thing to note for all these problems, you're either going to be given a graph or you're going to be given a set of points, and you have to identify the roots either way. All right, so to start off, I'm going to identify the roots. So my roots are where it crosses the x-axis. So I'm going to have negative 8, comma 0. And over here, we have 1, comma 0. So those are the 2 roots I'm going to work with. Now notice they also gave you the y-intercept. So you also want to be able to determine any other potential points if possible. So for example, down here, we could also have negative 3, comma negative 20, or negative 4, comma negative 20. You want to be able to identify as many other points as possible. And that'll be more apparent why later on. All right, so we're going to use those zeros to write the binomial factors. So we know our solutions here are x equals negative 8 and x equals positive 1. So I want to kind of rework these and reorder these so that they resemble binomials. All right, so over here on the left side with this x equals negative 8, I'm going to add 8 on both sides. I actually want to move it to the same side as the x value. So I'm going to have x plus 8 equals 0. And then over here on the right side, I want to subtract 1 on both sides. So I'm going to have x minus 1 equals 0. All right, so we have our 2 binomial factors here. So we're going to have x plus 8, and we have x minus 1. All right, so now that I have my binomial factors, now I want to actually multiply them. So you could either use FOIL or you can use box method. It doesn't matter which method you use. It's going to give you the same answer either way. All right, so I'm going to copy and paste from up here. All right, Notability just quit on me. Everything's fine. Okay. All right, so I'm going to multiply these using FOIL. FOIL to me is just quicker. So the first terms are going to be x times x, which gives you x squared. The outside terms, x and -1, are negative x. The inside terms are 8 times x, which give you 8x. And the last terms, which is 8 times -1, which is -8. All right, so I'm going to go ahead and simplify this. So I'm going to combine my like terms. All right, so I'm going to have x squared plus 7x minus 8 equals 0. All right, so here's the thing. Typically, a lot of people would stop here and say, oh, there's my equation. But here's the thing. You need to know what your a value is. You need to know if there's going to be a scalar or some sort of dilation in some way. So if there's a vertical stretch or a vertical shrink or whatever transformation there is. So technically, we're not done. So now we're going to write it in what we call the regression form. So the regression form is going to be y equals a parentheses whatever your equation is in parentheses, and we're going to actually solve for that a value. All right, so what goes in the parentheses is what you got in the previous step. So in step 3. So I'm going to write it as y equals a parentheses x squared minus plus 7x minus 8. Is that all I'm doing in that one? Yep. All right, so that's all you're doing for this step. You're just writing it in the regression form. So now we're going to take that regression form, and now we actually want to find that a value. So what I'm going to do is write the regression form, and I want to plug in a coordinate from the parabola. So back in step 1, when I was finding all those random points, that's where this is going to be used. All right, so you want to either plug in the vertex or the y-intercept if possible. I would say you want to prioritize the y-intercept. It's going to make the problem a lot easier since the x value is 0. But if they don't give you the y-intercept, then you may have to plug in another point. So the vertex is another good kind of go-to in case they don't give you the y-intercept. Or you can just plug in just a random point that's on the parabola. As long as the point is on the parabola, it doesn't matter what point you plug in. So one thing to note, you cannot plug in a root. We already used the roots to write the original equation. All right. If you plug in the root, you're going to get something like 0 equals 0, and it's not going to help you. It's not going to solve anything. All right. So kind of referring back to my graph up here, they gave us the y-intercept of 0, -8. So that's what I'm going to use to plug in. All right. So I'm going to make a little note. Plug in 0, -8. So I'm going to plug those in for x and y respectively so that I can solve for the a value. All right, so I'm going to have -8 equals a parentheses 0 squared plus 7 times 0 minus 8. All right, so we're going to plug in the x value twice. So the x value here and here, and then you're going to plug in the y value once. And then you're going to solve for your corresponding a value. All right, so we're going to have -8 equals a parentheses 0 plus 0 minus 8. So 0 plus 0 minus 8, it's going to give us -8. Now to solve for that a value, I'm going to divide both sides by -8. So when I divide, we get an a value of 1. So in this case, your a value is not going to change your equation. but if your a value is anything other than 1, that means it's going to change the equation. So what I'm going to do is I want to take this top line up here. I'm going to write it down here. So I'm going to take that a value that I just found, and I'm plugging it in for a right here. So when I plug in a, we're going to get y equals 1 times x squared plus 7x minus 8. But when I distribute that 1, it doesn't change anything. It's just the original equation, which means your equation is just y equals x squared plus 7x minus 8. Okay, so that's really doing it step by step. So now we kind of consolidate all the steps into one. Now we can start doing the problems. All right, so we want to use the roots to write the quadratic function for the parabola. All right, so remember, you have to start with the roots. So I'm going to start down here. So I know this is going to be -2, 0. And over here, this is going to be 6, 0. Right there. All right, so I want to go ahead and identify another point that I can plug in. So because they actually have the y-intercept right here on the graph, I'm going to go ahead and use that point. But just know you also have the option to use any of these other points. So you could use the vertex if you wanted to. So that'd be 2, 8. Or you could even use right here 4, 6. Yeah, that's pretty much it. All right, so you can use really any of those points, any 3 of those points. All right, so once again, start with the roots. So I have x equals -2, and we have x equals 6. So that's step 1. Step 2, now I want to write them as binomials. So to write them as binomials, I'm going to push the values to the other side. So I'm going to add 2 on both sides. And then over here, I'm going to subtract 6 on both sides. All right, so now I'm going to kind of bring those together so that I can multiply them. So x plus 2 and x minus 6. All right, so I'm going to do FOIL again. So when I do FOIL, you're going to get x squared minus 6x plus 2x minus 12 equals 0. So I'm going to combine like terms. So the -6x and the 2x will combine so that you get x squared minus 4x minus 12 equals 0. All right, so now I need to do the regression form. So I'm actually going to go over here. So remember, y equals a parentheses, and then the binomial that you got, or not binomial, the trinomial. All right, so now that I have it written in the regression model, now I need to plug in a point. So this is where I'm going to plug in 0, -6. Not -6, +6. So I'm going to plug in the y-intercept that's on my graph over here. So remember, the y-intercept is going to be your best friend to plug in. If they don't give you the y-intercept, use the vertex. If they don't give you the vertex, then plug in another random point that you, that you can find. There's always going to be some other point that you can find. All right, so over here, now I'm going to plug in 6 for y, and then 0 for your x value. All right, now I need to solve. So 6 equals a parentheses 0 minus 0 minus 12. So you're going to have 6 equals a parentheses -12. So I'm going to divide both sides by negative 12. So 6 divided by a negative 12, that's going to give you an a value of negative 1/2. So now I'm going to take the regression model from up here, and I want to write in the a value. So I'm just going to copy and paste the equation down here, and I'm going to plug in the a value. All right, so I'm going to have y equals negative 1/2 x squared minus 4x minus 12. All right, so when you get to this point, now you have to distribute that a value to every value inside the parentheses. So remember, every value inside the parentheses is going to get this value. So when you distribute, you're going to have y equals negative 1/2 x squared plus 2x plus 6. So this would be your final regression equation. All right, moving on to the second one. All right, so I'm going to go through this one a little bit faster since we've already done that first one. All right, so once again, use the roots. So this is going to be negative 5, 0. And over here, this is going to be negative 1, 0. So notice how up here, they don't really give you the y-intercept, so you can't really use a y-intercept up here tragically, which means we're going to have to plug in a vertex value. All right, so the vertex value over here is going to be negative 3, comma, negative 4. So that's what I'm going to use to plug in. All right, so once again, start with your roots. So we have x equals negative 5 and x equals negative 1. So you got to turn these into binomials. So I'm going to add 5 on both sides. So x plus 5 equals 0. Then add 1 on both sides. So x plus 1. All right, so now I'm going to take both of those binomials and I'm going to multiply them. So x plus 5 times x plus 1. So when you FOIL, we're going to get x squared plus 6x plus 5 equals 0. Now you need to write it in the regression model. So we're going to have y equals a parentheses x squared plus 6x plus 5. All right, and then the point I'm going to plug in is the vertex. So negative 3, negative 4. All right, so I'm going to have negative 4 equals a parentheses negative 3 squared plus 6 parentheses negative 3 plus 5. All right, now you need to solve for a. So negative 4 equals a times 9 minus 18 plus 5. All right, so 9 minus 18 is negative 9. Negative 9 plus 5 is negative 4. So we're going to have negative 4 equals a parentheses negative 4. When you divide on both sides by negative 4, you get an a value of 1. So an a value of 1 is not going to change the equation. So your initial equation that we had up here, that's going to be your equation. All right, so I'm going to copy that equation down here. So when you plug in 1, it doesn't change. So your final answer here, 1 parentheses, x squared plus 6x plus 5 is just going to be x squared plus 6x plus 5. All right, so now we're going to do some problems where they just involve given coordinates. So it's still the same process. It's still the same idea. The only difference is they don't give you a graph, they give you points. All right, so with number 3 here, you want to write the equation of the parabola that has a vertex of 8, 0 and passes through 5, 5, 9. So keep in mind, I gave you guys this hint on purpose. Notice how the vertex is a root itself. So just kind of a rough sketch, just so you guys know what we're working with. All right, so it's going to have a vertex of 8, 0 and passes through 5, 9. So like 5, 9 would be over here. And then this is going to be 8, 0. Okay. So keep in mind, usually we have 2 roots to deal with, but in this case, now we only have 1. So what that means is you can only work with that 1 root. So what that means is this is actually going to be a special case. So when I say special case, we're looking at using a perfect square trinomial. So the perfect square trinomial, so just an example, it's going to look like x plus 2 squared or x minus 5 squared. So it's just that one binomial squared. Okay, so over here, if our root is x equals 8, I'm going to subtract 8 on both sides. So I have x minus 8 equals 0. So because this is also the root, or it's also the vertex, what I'm going to do is I'm going to turn it into a perfect square trinomial. All right, so I'm just going to square the x minus 8. All right, so that's going to turn it into x minus 8 times x minus 8. So when you FOIL, you're going to have x squared minus 16x plus 64 equals 0. So that's what you're going to use for your regression model. All right, so we're going to have y equals a parentheses x squared minus 16x plus 64. All right, so the value I'm going to plug in, they only give us that 1 point, 5, 9. So that's what I got to use. All right, so plug in 9 for the y, and then 5 for your x. All right, so we're going to have 9 equals 5 squared, which is 25. Then minus 16 times 5 is at 80. Plus 64. All right, so we're going to have, is that 116, is that 9? So a value of 9. Just going to double check myself because, you know, math is always hard. Yep. All right, so when I divide by 9 on both sides, so we're going to have an a value of 1. So whenever you have an a value of 1, what that tells you is it's literally just going to be your original equation from up here. All right, so I'm going to copy and paste that equation down here. All right, sub in the 1. So because it's just 1, it's not going to change your equation. So your final answer is just x squared minus 16x plus 64. All right. So number 4. So for this one, now I give you 3 points. So here's the thing. 2 of those points are going to be the roots, unless I have a special case like this. And then the other point that I give you is specifically the point that you have to plug in for your regression model equation. All right, so look at the points that I give you. -6, 0, 3, -27, and 4, 0. So your 2 roots are going to be the coordinates that have a y value of 0. So you actually have to identify what the roots are. Now be very careful because I can give you 2 roots and I can also give you a y-intercept. So just keep in mind. All right, so once again, start with the same steps. So start with x equals -6, was 4, and x equals 4. All right, so turn them into binomials. So we're going to have x plus 6 equals 0. And we're also going to have x minus 4. So I'm going to multiply both of these. So when I FOIL these out, we're going to get x squared plus 2x minus 24 equals 0. All right, so I'm going to use the regression model. So y equals a parentheses in that same equation. All right, so I'm going to have y equals, nope, that's not what I'm doing. Plug in a point. My brain stopped working. All right, so I'm going to plug in 3 for my x and -27 for my y. So -27 equals a times 3 squared plus 2 times 3 minus 24. All right, so we're going to have -27 equals a parentheses 9 plus 6 minus 24. So this is going to be -27 equals a parentheses, is that -9? I always have to double check myself. Yep. All right, so I'm going to divide both sides by 9, -9. All right, so we're going to have an a value of +3. All right, so now I want to take my regression model equation. I'm going to take the equation from up here and plug in the a value. All right, so we're going to have y equals 3 parentheses x squared plus 2x minus 24. So when you distribute, so y equals 3x squared plus 6x minus 72. So this is your final equation. All right. So this is if you're doing all of them by hand. I'm also going to show you how to do these on the calculator. So the rest of these I'm going to do on the calculator. All right, so for these last three problems, so for 5, 6, and 7, so I'm going to do these by hand, but then I'm also going to go ahead and check them on the calculator. All right, so just as before, we want to start by finding the roots. So we have the coordinates -7, 0, -5, 10, and 5, 0. So of these 3 points, -7, 0 is one of our roots. That's terrible. And our other root is going to be 5, 0. All right, so as mentioned before, I'm going to turn these x-intercepts, these roots, I'm going to turn them into binomials. So I'm going to start with x equals -7 and x equals 5. All right, so of these values, I'm going to go ahead and turn them into binomials. So to do that, I'm going to add 7 on both sides. So I'm going to have x plus 7 equals 0. And now the other one, I'm going to subtract 5 on both sides. So x minus 5 equals 0. All right, so now I'm going to multiply both of these binomials together. All right, so once again, you can do FOIL or you can do box method. It doesn't matter which one you do. You should get the same thing. So when you FOIL or do box method, you're going to get x squared plus 2x minus 35. That's going to equal 0. All right, so now I'm going to plug it into the regression model. So that's going to be y equals a parentheses, and then that equation down there. All right, so the point I'm going to plug in is going to be the other given point from the initial question. So I'm going to plug in -5, 10. So I'm going to plug that in for my x and y value respectively. All right, so for my y value, I will have 10. That equals a parentheses, -5 squared plus 2 times -5 minus 35. All right, so I'm going to do 10 equals a parentheses 25 minus 10 minus 35. All right, so now I'm going to write everything together. So 10 equals a parentheses 25 minus 10, which gives you 15, then 15 minus 35, which is going to give you -20. All right, now I want to divide over that -20. So I'm going to get an a value of -1/2. All right, so I'm going to take my regression model from up here, and I'm going to plug in the a value. All right, so my a value of 1/2 is going to get plugged in, and I need to distribute. So I'm going to have y equals -1/2 x squared plus 2x minus 35. So when you distribute, you're going to get y equals -1/2 x squared minus x plus 35 over 2. So this is going to be our final equation, our final answer here. So what I'm actually going to show you next is how to actually do these on the calculator so that you can actually kind of check them. All right, so on your Casio, what you're going to do when you turn it on, you're going to go to statistics. So I'm going to go over to statistics. Now in list 1 right here, you're going to input your x values of the coordinates that you're given. And in list 2, you're going to put all the y values of the coordinates. All right, so our coordinates were -7, 0, -5, 10, and 5, 0. So I'm going to plug in all of those points respectively. So -7, -5, and 5. So those are all the x values Now I want to put in the respective y values. So I'm going to have 0, 10, and 0. So once I type these in here, then I can actually go ahead and do the regression model. So I can go ahead and I want to calculate. So I'm going to press F2. And I want to do a regression. So I want to press F3. All right, so up here, these are all the different regression models that your calculator can do. So F1 is linear, F3 is quadratic, F4 is cubic, F5 is quartic. And if you see this little arrow right here, if you press F6, it will actually toggle over to a whole other menu of different regression models that you can do. So you can also do logarithmic, exponential, power, sinusoidal, logistical, and then it'll just go back to the other menu. So we only want quadratic, so we just want F3. All right, and then it will give you the decimal values of your equation. So in this case, we have -1/2 minus x plus 35/2. So this is a great way to check it. You can even do the problems in here. Just know that your final answer may be a fraction or it may even be a decimal. So just keep that in mind. All right, let's go back to all right, so we did this one correctly. All right, so I'm gonna go ahead and do number 6, same idea. I'm gonna go through these a little quicker, and then I'll show you guys the calculator trick. All right, so once again, -5, 0, this is your root. Now 0, -20, this is actually a y-intercept. So you really have to pay attention to see what the x-intercepts are and a potential y-intercept. All right, and then 10, 0 over here, it is a root. All right, so once again, start with your roots. All right, I'm gonna move these over here. All right, so now we need to turn these into binomials. So I'm gonna add 5. So I'm gonna have x plus 5 equals 0. And over here, I want to subtract 10. So I'm going to have x minus 10 equals 0. So these are my two binomials. So now I want to multiply these together. So when you FOIL these out, you're going to get x squared minus 5x minus 50 equals 0. All right, so now I'm going to plug this in the regression model. So y equals a parentheses x squared minus 5x minus 50. Now, I want to plug in my other point. So I'm going to plug in 0, -20. All right, so when I plug in, what you're going to do, you're going to have -20 for your y value, and then plug in 0 for your x values. So we're going to have 0 minus 0 minus 50. All right, so I'm going to have -20 equals a parentheses -50. So when I simplify, we're going to divide over that -50. All right, so you're going to get a equals positive 2/5. So your a value in this case isn't all that pretty, but it's okay. So now we just got to plug it in. So I'm going to plug it in to my regression model up here at the top. This is what I'm going to plug it into. All right, so I'm going to copy it down here. So I'm going to plug in that 2/5. So I'm going to have y equals 2/5 parentheses x squared minus 5x minus 50. So when you distribute, you will get 2/5 x squared minus 2x minus 20. So this is your final equation right here. All right, so now I'm going to go ahead and check it on the Casio. I'm I'm going to use the calculator trait. So to get out of this menu, I'm just going to press exit. I'm going to go back to the list. And I just want to get rid of all these. So I'm just going to delete. And I want to kind of replug in those points. So I have -5, 0, and 10 for my x values. Then I have 0, -20, and 0. So once again, I'm doing a regression model for x squared. So here's my points. So I have 0.4, -2, and -20, which match my original equation. All right, so we're good to go on this one. All right, and last but not least, same idea here. All right, so identify your roots. So we have a root here at -6, 0, and we have a root here at 3, 0. So start with your roots. So x equals -6 and x equals 3. All right, so turn these into binomials by doing inverse operations. So I'm going to add 6 on both sides. So x plus 6 equals 0. And then I'm going to subtract 3 on both sides. So x minus 3 equals 0. All right, now I need to multiply those two binomials. So x plus 6 and x minus 3. So when you multiply, you're going to get x squared plus 3x equals minus 18 equals 0. All right, so now I'm ready to do the regression model. So y equals a parentheses x squared plus 3x minus 18. All right, so the point I'm going to plug in is going to be this kind of gross, nasty one. So -3/2 common -27. So I'm going to have -27 equals a parentheses. Oh, wow, this is going to be truly awful. -3/2 squared plus 3 times -3/2 minus 18. And if you are like me and you don't feel like giving yourself a headache, I'm actually literally just going to plug all that in the calculator. If you want to do it by hand, you go for it, Glen Coco. All right, so we're going to have -27 equals a parentheses, or actually, let's do it over here. All right, so on the Casio, I'm going to go to run matrix, and I'm literally just going to plug it in. So open parentheses, so -3 over 2 squared, then plus 3 parentheses, fraction, -3 over 2, then minus 18. And you get this disgusting value of -81 over 4. All right. So now I need to get rid of this -81 over 4 over here. So what I'm going to do is multiply by the reciprocal. So I'm going to multiply by a -4 over 81 on both sides. All right, so when you do that, I really should be doing this in my head, but you know what? I don't want to give myself a headache, and I don't want to give you guys the wrong answer. So we're going to get positive 4/3. All right, so that's your a value. So now I'm going to plug in this a value to your regression model, which we have up here at the very top. All right. So plug in the 4/3 times x squared plus 3x minus 18. All right, so when you distribute, we're going to have y equals 4/3 x squared plus 4x minus 24. Wow, my handwriting is terrible. All right, so now I'm going to check it real quick using, what's it called? Calculator, Casio. There we go. All right, so I'm going to go to menu, statistics. I'm going to get rid of all this garbage. And I want to plug in the new points. So -6, -3 divided by 2 for -3 halves, and 3. Now I want to go over here, plug in the corresponding y values. So 0, -27, and 0. All right, now I want to do a calculate. So F2, I'm going to do a regression model, F3, and I'm doing a quadratic equation, so F3. So there's your values. So 1.3 repeating is the same as 4/3, 4 matches, and -24 matches. So we are good to go here. So that's what we're doing.